Welcome back after lunch. What an awesome summit. I love, this is my fourth one. This is really cool. Is this amazing or what? Those of you that are your first one, you're like, I don't know, it's kind of small. But this is amazing because we got, it's amazing for me because I know so many people in here. I know your use cases. I've probably been on site at where you work. I probably met you at a meetup. And it's just really neat to see everybody show up and talk to each other. I mean, how many of you have been in the Cassandra live room and got, yeah, come on, lightsabers, got to play a little Call of Duty in there. I played for like 5 seconds and remember why I suck. And then somebody says, you know, that's a bot. I thought it was like somebody else. I just kept getting killed. So anyway. So speaking of, it's been quite a year. An epic year. Hey, I put Call of Duty on there, guys. So this is what I've been doing. So since last summit, when I talked last, I've had a couple of projects I've worked on, and it is so cool because they're here today. Sony, talking about PlayStation 4, launching PlayStation 4 with Cassandra on the back end. Tim and Sean over here, talking about how they launched Call of Duty. I gotta show up in Vancouver, because you're like, well, we're gonna launch this game on Cassandra. You better be there in case something happens. Most boring week of my entire life. Thank God, right? Because that's what I always say. Cassandra should be the most boring thing in your infrastructure. Totally was. It was ridiculously boring. They came over and said, they kept apologizing. I'm sorry. There's nothing going on here. So I got a lot of emails done. So I've been, it's great because now you're coming to my house. I live around here. I've been all over the world this year. And everyone I see out there, I mean, it's just amazing. I went to Warsaw, Poland. Had a meetup. 50 people RSVP'd. 75 people showed up. I never had that happen before. I mean, they had people piling out of the room. The amount of interest in Cassandra worldwide is amazing. I'm heading back to Australia shortly, and it's going to be even bigger there. I'll be back in Europe twice this year, just because there's just so much going on there. And of course, I think there's something going on in the United States. I'm not sure what, but. So let's get into this. So 2.1 dropped today. How about that, huh? And what was great, and the story behind it is always fun, you know, all the things that happened, 7 RCs, that's a lot, but it just shows you, like, things are starting to grow up a bit in Cassandra land. And so huge changes in this. I mean, we're talking, the performance changes alone are amazing. But the data model is definitely different. And, of course, that's why you're here to hear what I talk about. But those amazing changes in that, the performance is really, I mean, that's just a little shape of what's to come. And you look at what, you know, those of us in this room that have been here since like 0.6 or 0.7 Cassandra, you know, this is amazing to watch. 2.1 is really an amazing, different tool. And I just love to see the progress. So many contributors on open source. Has anyone in here contributed to Cassandra open source? In any way, docs, Jiras, anything. I see a lot of hands. I'd like more hands. But this is we own Apache Cassandra. It's an Apache project. DataStax doesn't own Apache Cassandra. I'm glad, I love DataStax because they hire me to come out and talk to you about this kind of stuff. And it really helps grow the community. But it is an Apache project. And it's really cool to see community people working together, talking about what they're doing, and making this a better thing. Because it's ours. It's ours. So 3.0 is next. So that'll be my next year's talk. Just hang on to your hat. It is going to be amazing. I got to go to the committer conference back in June. And I'm not a committer, by the way. I play one on TV. But just the things that are being talked about, not just dreamed about, like spec'd out, are amazing. Huge changes coming. And it's more performance, more usability. The operations people are going to love this. More importantly, developers, who are near and dear to my heart, are going to love this even more. And so just hold on. So what's coming up? let's talk about a few things here when it comes to data modeling. So I don't know if, was anybody in here in my first talk about killervideo.com in 2012? Anybody at all? Nobody. Oh, maybe. Where? Oh, Charlie, of course, if you were there. You've been there since the beginning. Yeah, he was my grade school teacher. No, I'm kidding. That's right, you were. So you remember killervideo.com? Hey, I'm just going to talk to Charlie here. You remember killervideo.com? We made it bigger. Yeah. So the 2012 summit, I talked about this crazy website with this crazy cat called killervideos.com. Come to find out I could only register killervideo.com. And it was supposed to be this complete example. And I wanted to have something that was, fake, but had a real feel to it. And it was just, I think a lot of us have seen Twissandra. I wanted an alternative to Twissandra, because that just didn't appeal to me. Well, it's gone pretty well, and it has good legs on it. We have really changed things quite a bit. So, whoa, backwards. Jonathan did that. We are now taking this thing to a real website. It's actually there. If you go to killervideo.com, it's a real website. It's hosted on Azure. The code is up on GitHub, and it actually looks real, too. I mean, that's better than my little cat picture, right? We had a contest for the design. That design's not up yet. But here's the point. We want to have a living website that we can talk about data modeling, that we can all participate in, that you can download examples, we can code against, we can do things with it, we can do crazy stuff, and even highlight new features. So we just last week, with brand new features in 2.1 that are just getting baked, we're going to start integrating those features directly into killervideo.com. And with the drivers, the way that they're working now, if you notice, the drivers are all matching the version of Cassandra now. Do y'all notice that? When 2.1 dropped, all of a sudden, here's all these announcements about drivers dropping as well. Same story. Now you can use 2.1 today with the Java driver, C#, Python, C++, Ruby, Node.js. Yeah, those just shipped. So we're going to try to create this, my Evangelist team, we're trying to keep this alive as just something that you can use as an example. More importantly, what I want to do is I want to put this data model in open source Cassandra in an examples directory. So when you download Cassandra, you have an example database installed. I mean, would that be helpful? Would you guys want that? Yeah. So hey, if Microsoft Access said Northwinds, right? So that's the intent. That was really tepid. That was a Monty Python. And the people rejoiced. Yay. So let's dive into this a bit. So I'm going to revisit that data model, and I'm going to toss in some 2.1. Jonathan talked about it this morning in the keynote, and I know that Aaron did some talking about some things that are happening. Let's just go into this. Now, what I'd like to do is let's hold off on your questions. I'm going to leave a big gap at the end, because I know how these things roll. I know how you are. You're all questioning. I'm going to leave a big gap at the end. And I hope that we have microphones. Ask a question. We're going to answer it. Nothing personal, like weird shit that I hate answering. No, I'm kidding. We want to answer. I want to answer all the questions you have about what I'm talking about, because I know I'm going to leave out something, or there's something that's burning issue in your mind. I want to hear what it is, because this is being videotaped. People are going to see this. They're going to probably have a similar question. So speak up, and we'll do that at the end if I don't go over time, which I should. So what are we going to do with these 2.1 data models? We're going to replace, but in a lot of cases, we're going to remove a lot of app code. Now, remove app code. Why would we do that? Now, I know that a lot of you probably write a lot of app code because a certain feature is not in CQL, or that you need to account for something in the way Cassandra manages its data. So that's not really efficient from an application standpoint. It doesn't make an application developer's life better. So when we put it into the Cassandra data model, it's going to make your life better, right? Oh, that's one less thing I have to write. That's less code I have to unit test. So for those 5 or 6 of you that unit test, oh, I'm all TDD. No, you're not. I heard a nervous laugh or two. So let's start right out. Yeah, me too. So I got the user-defined types. And now, this to me was the killer feature. And Jonathan talked about it a bit. Let's really get into this, right? It means that now we can start mapping our complex data in one place. I've participated in some funny data modeling sessions where we took some complex data and did some really complex things to it. And I even think in that discussion, I said, boy, I can't wait for UDTs to drop. Well, they're here. And so what we hope we can get out of this is it eliminates the need for a lot of multi-gets, like an in, or whenever we say, I'm going to go grab multiple rows of data so I can pull it together in memory. And you get to do things that you probably are doing already. And that's nesting data, nested data structures. We have collections. Those have been working awesome. I've been doing a lot of cool things with those over the past year. But let's just take this a little further out. So here's an example. I have my before. So before I wrote this application, so this is off of killervideo.com. I had videos and video metadata. So the video metadata is just, all right, whenever you encode your videos, you're going to have some stuff in there, like the height and the width, the bit rates. And those are all, usually you have several of those. And if you've done any work with video, you know that you have to account for like an iPhone or an Android or a Galaxy or some other kind of device that has to have a certain resolution. So you need to have a list of those. To this point, up to this point, we've been doing these separate tables, so they're kind of disjoint in a way. Not too bad. It's not something that really required a foreign key constraint, but it is something that requires a second get. So in this case, we say videos is in one table, and your video metadata is in another. And the video metadata has a UUID that points back to the video. Now, when I want to grab all of the video metadata for a particular video and to find out which play speeds I have, playback speeds or bit rates, I'm going to have to do a select from videos first, and then I'm going to have to do a select from video metadata next. And then what I have to, unfortunately, do is some sort of an in-application join where I combine the data and then I create this, this data that is on your screen here. Like, and these are what you would expect to see on a playback screen. Like I can do my playback rate or as my title and description, and a few other things like comments and what have you. But that required extra code to do. That's a bummer because now we're spreading data around. We get into these discussions about, well, what if I have the situation where I'm setting one table and I'm not setting the other? That's a bummer. I don't want to do that. That seems stupid. Get out of my house. So I don't want that. We want to pull it together. So now with UDTs, what are we going to do with this? We're going to nest that puppy. We're going to put it right inside the videos table. So now I have a type, video metadata. And that video metadata contains all the fields that I wanted. It has the height, the width, video bit rate, and it has a set of video bit rates. Awesome. And an encoding, what kind of encoding it is. And I put that back into the video table, so this metadata now is another set of video metadatas. Frozen metadatas. That's right, it's cold. No, I'm going to talk about frozen in a minute. But now I have embedded all that stuff into one single partition, meaning that whenever I go to get that data, it's a single storage row. On the disk, all this data is co-located. If I had two different tables, potentially I'm going to have on two different nodes. It's no longer co-located. And if I ask for all of that data in one pass, I'm not going to get it. I'm going to have to go do a couple of things. And one of those queries might time out. So now it's all built in. And if you notice, I have a set of a set. I now have nesting going on in 2 layers, which is pretty cool. So there is that one word there, frozen. I had to. This was, boy, ooh, yeah, boom. Yeah, that's what I said. This is one of those things, man, I didn't tweet it. I wanted to, but it would just be such a troll on my own thing. Frozen, what does that mean? It's not Olaf dancing around talking about schema, although, and Jake, are you in here? You were supposed to sing this. No, all right, he left, he knew. I told him he was gonna have to sing this and he bailed out on me. So, The whole idea of frozen is really an attempt for us to stay out of technical debt. What do you mean by that? Frozen in this case means that it's somewhat immutable. And I struggle with using words because we got into this huge argument about what the words mean. If you say static, what does that mean? If you say immutable, what does that mean? But Jonathan mentioned it this morning, but really what we're saying is that that is going to be fully defined whenever you create it, and you don't have to recreate it to change it. And so frozen in 2.1 makes sense because there's no dynamic part of that. You can't grow it out in any way. So in 3.0, you will be able to do that. So by enabling the feature in 2.1, without having the dynamic portion of it, we just put the frozen keyword in front of it to keep it useful. But then whenever, you don't want to have this like Python 2 to 3 fiasco where, oh, we were using 2.1, and when we started using 3.0, everything's wrong again. No, we don't want that. Because if you start using UDTs, and I guarantee you after this talk, you're going to go out and use them. Probably incorrectly, and we're going to try to fix that. But, oh, I can't wait for that phone call. Dude, I use UDTs and my house is on fire. Wait for it. But we want to make sure that whenever you write your application code using UDTs, it's forward compatible. So that's what this is really about. So when 3.0 drops and you don't use the word frozen, cool. If you use the word frozen, cool. So yesterday I had a data modeling class, and we were talking about all these different, 8 hours of data modeling, and I'm doing another hour today. So 8 hours of talking about data modeling, and what was the favorite topic everybody wanted to do? I want to store some JSON, dude. I put this one slide up. How many of you were in my data modeling class yesterday? Oh yeah, this slide made you come to this talk, didn't it? It was pretty bad. It was blatantly bad. I apologize to all the other speakers in every other track. I totally trolled you. I put this slide up and now I drug them in. But this is what I want to do, right? Here's some JSON. What do I do with that? There are people in this room that I've had the most intense conversations with. It's like, dude, I got JSON. What do I do? Like a total Captain Kirk. What do I do? Because it's like, it's nested, and it looks like a schema, but it doesn't fit into anything because it's not flat. I can't denormalize this. So what do you wind up doing? Unnatural acts. You start pulling things apart. You start pulling out fields. You flatten them out. You create hashes of things. It's just a mess. So we don't want that. Now, the new story. What am I going to do with this? This is a product, just a product in a catalog somewhere. It has an ID, some descriptions. It has some dimensions, and then some categories. And those categories, they could be multiple ones. Like, where does it fit? It fits inside home furnishings or in kitchen furnishings. Those are different places where it fits. So this isn't that crazy of a JSON. And I've seen some crazy ones out there. And thank God it's not XML. So I'm going to pick this apart. First part, dimensions. All right, I'm going to create a type for that. I create a type called dimensions, just all those fields that I want, and I'm giving it a fixed schema. I'm saying, no, length needs to be a float. Width needs to be a float. That's good. Don't put in a text. And all this is now defined. What about category? Whoa, back up. Oh, the big reveal happened. Failed me. Category is now also just a little tiny bit, but I know that I'm going to have the same thing. It's repeatable. So a category page and URL, awesome. I have a couple of those in there. So now this isn't even exciting anymore, but here you go. The product table now has everything, the entire JSON in it. All right, that is cool. Now I have my dimensions, which are a fixed UDT, a user-defined type, but then I have my categories, which are a map. So whenever, if you look at what I actually have here, category, home furnishings, my map key is home furnishings and kitchen furnishings. And the object that it contains, or that's contained, is the category itself. I just embedded nested JSON in one CQL row. That's pretty cool. I just saw some people downloading things now. So now, whenever, this is an insert statement. So when I insert this into Cassandra, I say insert into, the units go into dimensions, and then this is actually an insert statement. Now I busted it out to make it look all JSON-y, but that's what it looks like, and that actually works. This is very usable. You could use it today. When I upload these slides, you can go get them. So this is now something you could store in Cassandra. So what about retrieving? This is where 3.0 will make these things a lot easier, but for now, this is one that we have. If I want to get the height, I just say dimensions.height. Awesome, boom, 32. And if I need to grab the categories, because it's a map restrictions still hold, I have to grab the entire map as a single pass, so the whole entire thing. That will be changing, though. But for now, I got a map of all my categories. And that's great. I got all that in my application code. It's a lot simpler. No more marshalling out all this crap that's in my JSON and finding places to put it. No more of that. So that's the new. Now, here's something new that was old. Counters. I love this Hacker News onion. It was clear to me that someone at Hacker News was a Cassandra user when I saw that. So, I don't know if you saw it. We had a little news at DataStax. Somebody gave us a big truckload of cash, and that's cool. Apparently, it's all to make counters work. Well, I'm happy to say, keep the change. Because it's gotten a lot better. Maybe they didn't know. I don't know. But, so we're going to have another summit because we have extra money now. So counters have been around since 0.8, thanks Twitter. And commit log replays has been really the biggest problem. If you do a replay, as Jonathan said, it changes your counter. Oops, that went up a bit. And repairs, because no one does repairs. Repairs can change counters too. These are things that make me say, don't use a counter, ever. And the performance, because even if you did use them, was always a little inconsistent because of garbage collection. Because it would yank all the stuff into the heap, put these big fat slabs of memory into the heap, and you get promoted into old gen, and then it wouldn't get CMS properly, and it would start doing this thrashing business. Counters were a problem. Not as bad as super columns, but pretty bad. And so it just has been this lingering technical debt forever. And they just look so good. You want to use them, right? Well, that's time for a wrecking ball. Boy, I was so close to putting a Miley Cyrus picture up there. And I saw it on my slide, and I'm like, oh, no. I just can't do it. I can't promote that. So I just put a regular one up. So, sorry, you could thank me later. So what happened? What's so good? Jonathan explained a little bit, but really what it is just kind of an internals rewrite, and just taking it and saying, whoops, mistake. That was a big problem. The good news is now it's stable under load, and you can now do a commit log replay. Woohoo! And those repair weirdnesses are gone. Yay! I think those two issues right there make it really useful. And that's still, it just takes away a lot of the problems. And the stability, I mean, look at the stability. The blue line is what I've been used to. The top one is for uncontended writes to counters, and the bottom one is for contended. The uncontended ones, man, the GC was just a mess. Uncontended, yeah, you kind of had hot sets going in the heap. But you just never got consistent performance. And GC pause, let's face it, that's going to kill your 95th and 99th percentiles. So you don't want to use that. We fixed that. That's good. And so you should try them out in 2.1. There's still some issues that we need to talk about, though. And that's my sad panda. Doesn't he look sad? You still can't do delete. I know that's a bummer, but that's something that's being worked on. And you still need to do a read before write internally. So the internal implementation still does a read before write. If you are using counters on a really weak CPU system and you're using compression, I'm telling you right now, turn off compression. Compression will thrash the living hell out of your CPU if you're using like an M1 large in Amazon, which I know you can't buy too many of those anymore. They're hard to get. But if you have just a couple of cores that read before write on a counter and you're compressing it, will cause all kinds of trouble. That's still going to be a problem. But I suspect most of you are using like 32-core beasts with 128 gigs of RAM and SSDs, so I'm not talking to you. All right. So, usage. How do we use these new counters? They're so cool, right? They're fast. It's pretty much the same thing. No change to the API at all, which is great, right? And that's actually a good feature right there. You still have to, when you look at your counter, you can just do a +1 or +3 to increment, or -1, -3 to decrement, and it'll increment or decrement your counters. Just that simple. So if you have counter code out there and you upgrade to 2.1, it's still going to work just fine. That's good. Next topic, static fields. So statics are new as of 2.06. They have a very specific use case, and I'm going to cover that real quick. And Thrift people will love this, because what it did, there was a complaint about the Thrift and Thrift implementation of how you put data into a storage row that just was not possible in CQL. Well, that has been fixed. So why static? So here's a couple of examples. My world-famous weather map. So we have a weather station, and we have an ID, a timestamp, the weather station name, and a temperature, like what temperature you're collecting. Before we had static, if you look up here, because the primary key had a partition key and a clustering key of ID and time, that means weather station name and temperature had to be included in every single partition or every single row in that partition. So that duplicates data across. If the weather station name is always going to be the same, which I guarantee it will, it doesn't change, it's still the same thing, then that's just kind of a waste of space. This also it also can create problems. Jonathan's example of bank balances where you just have one balance, you don't want to update all of them. That's another edge case that's a problem. So now whenever we add static, what you're saying is now there's just one of these in the storage row, and it's in the beginning. Now when I put weather station name as a static, we're looking at the storage row representation here. This is the graphic. It's going to have name one time, and every single CQL partition will just have temperature in it at that point. Much more efficient, much cooler. I'd rather see this. It's going to save a lot of space for just this one use case. I'll bet you have some use cases right now you can think of where this would apply. Now, there are some things you have to make sure. You put the static at the end of the declaration. It cannot be a part of the primary key, because that's a clustering column, or it's your clustering key, which would be your row key in the storage engine. But pretty simple usage. You just put static at the end, move on. So this one, I expect to see that quite a bit this year. Now, here's the type that I struggled coming up with a reason why I would use it. I'm going to be honest. But after I talked to a couple of the committers, I realized what we're showing here, what's actually happening is we're bubbling up something that has to be there for a lot of other things like UDTs and unfrozen UDTs. But there are some people that would ask for it. It was just easy enough to expose. So let me explain what this is. This is the tuple type. And yes, you have to freeze these guys too. But a tuple type is really simple. It's just a collection or group of attributes. Like I want a 3-tuple with 3 things in it, an int, a text, and a float. Just enumerate it out. Or a 4-tuple with int, text, float. You can have, I said 256. That was wrong. I put a sign in front of it. It's actually 32,000 elements in there. And it's really simple to use. You just create a group of things, and you can store them all as a group. Not a lot of use cases, but I found one. And it's actually pretty appropriate, because we do have a drone flying around here somewhere. What if we had, in a Cartesian plane, we had X, Y, Z, or Z for your Canadians in here. I'm multilingual. So if you have 3D Cartesian coordinate, well, that fits pretty good. It's a tuple, X, Y, Z. And when we have that just to store as a group, I'm not breaking it down. I'm going to store that. So you can see I have my position as a tuple, a 3-tuple, and storing that in as a time series. So whenever I need to know where my drone is exactly in a 3D coordinate, I can just pull that out. So if you have drone issues, there's your data model. That's free. Final little bit here, and I know I'm dwindling down on time, so I better hurry up. So partition size. Besides, oh my God, eventual consistency is killing me. I don't get it. After we get through that, the next thing is, wait a minute, how big of a partition can I create? That's always the next step for me. And so I spent a little bit of time. A CQL partition is really a projection of a storage row. If you watched my data modeling talks, you know I talk about that, the storage row underneath. Stored on disk, right? And a storage row can have up to 2 billion cells. That's a lot. Now, I always get people to say, well, you don't really store 2 billion cells in there. Well, I don't know. Let's find out. So it can also hold, each cell can hold up to 2 gigs of data. That's a lot of data. 2 gigs times 2 billion, I didn't do the math, because it's stupid. Well, it's good to do math, kids. Stay in school. But that math is stupid for our discussion, because if anyone ever did it and called me and said I did it, I'd say you're stupid. That's what I meant. So how much is too much? How many cells before it degrades? How many bytes before it becomes unmanageable? What is practical in this case? So practical meaning like, how would I store this? So Aaron Morton, who was on stage here earlier, and if you saw his talk, he actually went through this exercise with 0.8 in 2011. And I've used this. I've done this. I've referenced this like the holy world. Here, do not do anything other than what's written in this blog post, because he tested this out. How big of a partition is good? Or how many rows would you put or how many cells would you put in a row? And it's a great blog post, but it's old, right? Things have changed. His conclusion, which has always been mine, is keep it less than 10,000 cells, keep it below 64 megs of total size inside of it, because you have multi-pass compaction problems, practical advice, and multiple hits to those 64K pages of data, they just induce more seeks. And that's bad. More seeks are bad. You've heard me say this before. Seeks are bad, okay? Keep away from that, and you'll be okay. So it's a performance tunable. You need more performance, shorten up those rows. I didn't like that answer for 2014. So I decided to redo this. And to redo this, I tried to reproduce the same results. He did it with Thrift and Python. To reproduce that, I did it in CQL and Java. Not exactly apples and apples. So I did represent what the intent was of those. And so I have the code. I'm going to probably, after this, I'm going to be writing a blog post about exactly how I did it, because it's way more than this talk for those of you who are interested in the nerdy details. But what I did was I said, all right, I'm going to start with 100 cells in a partition all the way up to a billion. A billion. That's right. Billions and billions. So the results were actually pretty surprising. When I got up to 100 million cells, the performance really didn't degrade that much. And these are in milliseconds. So it went from 300 microseconds to 600 microseconds. The test was, it did a run of 100 per test. And I was doing things like random reads in the middle, or grab 100 cells from the end, grab 100 cells from the beginning. The only one that was really consistently low was grab it from the beginning, which is right there in that blue line. And it seemed like that sweet spot was down there at the 5,000 or 10,000. But even when I got up to 10 million and 100 million, it wasn't that bad. Aaron's test showed that it just went off the chart. Now, if you'll notice, I didn't put a billion on there. Yeah, it didn't work so good. For a different reason I didn't even think of. It was an operations problem. I had one huge, massive 27 gig compressed row. One partition of 27 gigs. My laptop didn't like that. So I got a problem. But I'm going to try to solve that. And it was actually grabbing all those indexes and putting them into the heap caused a lot of issues. So that's already been addressed in a JIRA. Hopefully that will get fixed as we go along. But what I did find, if I broke up those SS tables into a lot of chunks, it wasn't that expensive. I was getting pretty usable performance at 1 billion cells. So what's the new answer? The new answer is hundreds of thousands is no problem. Hundreds of megs per partition is probably the best thing operationally. I'll tell you, 27 gigs in one partition, We're not quite there yet. Your operations people will probably plan your disappearance if you do that. It was just hard to manage and get things moved around, but I think that's going to change pretty quickly. And it's really an operations issue when it comes down to it. If you're trying to follow some guidelines or some limits, these are just guidelines, Like I said, I will be following up the blog post on this, give you all the gory details and the code so you can run it at home. Maybe you got a bigger laptop than I do. By the way, I had SSDs, of course. So that's the new answer right now. And I'm really happy about that. And a lot of it has to do with like the index promotion into memory. That's really good. And that was as of 1.2. So things are getting much better for these really, really, really wide partitions. So what we are going to do now, I have exactly 7 minutes. Thank you very much. Let's get some questions. Oh, and follow me. I don't know what my Twitter handle is.